Hello and welcome. My name is Bob Tickelman. I'm a Microsoft Technical Trainer, and I want to welcome you to this session of what you want to know when you want to know it. We're going to be discussing designing Microsoft infrastructure solutions as part of the AZ-305 designation. In this module, we're going to be looking specifically at the various compute solutions that you have available to you across the three different areas of what is referred to as cloud solutions, whether it be our cloud or any of the other vendor clouds. We're going to focus specifically on the first two of IaaS, or infrastructure as a service, and then we'll be taking a look at the PaaS, or platform as a service offerings. The lessons that we're going to be covering specifically is what are the compute services that are available to us, and we have a chart that we'll introduce you to that allows you to simplify some of those first choices. And in many cases, there's rarely one entry or exit point from it. You might have several options, and you want to think about which is going to be the best to meet your needs from a cost perspective, scalability perspective, future-proofing of the deployment of the applications. Those will all be looked at in that solution there. We then want to take a look at a feature called Azure Batch. Now, this is not for everybody, but it is a feature of cloud computing that if you needed that capability, absolutely available to you. So I think it's nice to have that on your tool belt of tools, of things that you can deploy. Taking a look at the app services, this falls very heavily into that PaaS, or platform as a service. And this would be my personal recommendation. If you were to take a look at the starting of a cloud journey, you want to free yourself up from that typical virtual machine or infrastructure as a service environment. These are where you can take that traditional application deployment environment and look at the app services and the app service plans to be able to look at this from a deployment perspective. We then take a look at some of the modern methods to deploy applications in a platform as a service, taking a look at a thing called a container, and specifically Azure Container Instances. We've got a variety of capabilities in here. You can have standalone individual containers. In fact, a container can be part of an app service plan in the previous component we just discussed, as well as you can go to a full AKS, or Azure Kubernetes solution, where you have Kubernetes orchestration managing your containers, and you see that one falling right in line with the container instances. We're then going to take a look at a feature called an Azure Function. Now, this fits in line with some of the other services as well. You can have an Azure Function that becomes this highly tuned piece of code. It's not typically your big application that has hundreds of lines with if-then-else statements. It is a feature that is part of the modern microservice application deployment, where you have these very small, highly tuned, performance-based pieces of code that combined together provide the glue that holds your applications together. They can exist as part of an app service plan listed above, as well as they can be standalone in a term called serverless. So we'll take a look at Azure Functions. And then kind of their bigger brother version, a thing called a logic app. And this becomes that low-code, no-code component for you to be able to actually literally drag and drop pieces of a solution together. So you don't have to be a coder. If you wanted to build an application and you had the logic behind you, you could go into a graphical representation, make connections to social media sites, and not have to know the API specifically. You can then, it'll ask you for the login credentials for that social media site, and then you could then drag in a piece that would search for a feature. So Logic Apps is a great component to be able to build that low-code, no-code features. So let's get into these compute solutions. Today, we're going to be taking a look at Azure architecture, and specifically the choice of which compute option we should consider. Let's get into it. When you take a look at a cloud environment, there are three major groupings of services that we provide. They're referred to as IaaS, or infrastructure as a service, PaaS, platform as a service, and SaaS, software as a service. The vast majority of what we're going to be taking a look at fall into one of those first two categories. Infrastructure as a service provides a traditional environment for you to build and host virtual machines that run very similar to the virtual machines that you're probably running on premises. The second option is the ability to use a platform as a service that varies widely in the offerings that it has, whether it be us hosting a virtual machine, much like the first ones that you would be building, but you don't have to maintain and manage them, but you get to consume the resources exactly the same way that you would before. We'll take a look at that in a thing called an app service plan. You can use a modern version of an environment. You can take a look at Kubernetes and the containerization environment. We offer a set of that in the platform as a service where you can consume a Kubernetes environment and container world and not have to manage it, but you can use the resources of containerization to deploy your applications. And we'll take a look at some of these high-end solutions like Azure Batch for high-performance computing. But this diagram is just showing you several pathways across the bottom and across the right-hand side that will show you, the outcomes of maybe a couple of choices, but rarely are there a direct path that it's going to answer it one way or another. I think understanding what each of these services does for you and then assessing whether your application or your organization can support the deployment, I would often try and find a pathway to a platform as a service as a modern way to deploy in the cloud. Many applications that run on premises, that run on virtualized environment, many of them, as I said, can either move directly into a platform as a service offering. And I would try and find that pathway first, as opposed to just defaulting to deploying infrastructure like you are right now into an infrastructure as a service or VM. We're going to be looking at Azure architecture, and we're specifically looking at virtual machines and how we can use them in the IaaS or infrastructure as a solution offering within the cloud. Let's get into it. When we take a look at the different offerings that we have of IaaS, PaaS, and SaaS as ways to consume resources in the cloud, one of the most traditional and easiest for customers to understand is working with an environment that they're probably very familiar with, virtual machines running on some hosted environment on premises. What we're doing is very much the same thing, except you're using our hardware on our infrastructure. And I want to give you an example of why you might want to consider even running your virtual machines in our environment, because we can do it at a scale and an opportunity that is very hard for you to match on premises. We offer you a wider range of services as well as a wider range of variety of virtual machines to be able to get in and work with. And so you can actually take existing environments and know that they will migrate to the cloud very well. So there's a whole bunch of reasons, when to use the virtual machines, especially if your applications can't run, if you want to just, maybe you're getting to the end of a hardware life cycle of on-premises resources and you don't want to repurchase that. You can move from a capital expenditure budget to an OpEx and just say, temporarily, we're going to move these VMs into the cloud, pay for them on a monthly basis because we're going to deprecate them over a period of, maybe a year. I don't want to buy them for a 3 to 5 year period on a capital expenditure. I'm going to move this stuff to the cloud. If you've just bought a whole bunch of brand new hardware, you're probably not going to make that the biggest candidate to try and move to the cloud. But absolutely, depending on life cycles and your need and want to be able to manage those resources on premises, moving something in an IaaS environment without having to go to PaaS might be a very good option for you. So here's one of the reasons why you might want to take a look at Azure for the hosting of your IaaS world. What I'm showing you on the screen right now is an example of US East, which is one of our regions, the term you'll hear us use quite a bit, that we deploy our resources. So this is US East. And this is what it looked like in 2014, that upper right-hand circle. And it's showing you two different versions of data centers that we were working with, each one of these being a unique data center. And inside of that data center are what you would have seen as racks of servers. We call them scale units. And here we exist in 2017. We're now dealing with all of these are 8 gigawatt data centers being brought in. So massive capacity and the capability for you to be able to use a wide variety. We've got virtual machines that range from as little as 1 core and a half a gig of memory to VMs that have 500 or 600 cores with up to 24 terabytes of RAM. So being able to have that flexibility to pick and move between them as opposed to being stuck with the hardware that you bought 3 years ago. If you find that your old hardware that you provisioned in Azure is no longer meeting your needs, it's very easy to then take that workload and upgrade it to newer hardware itself. Taking a look at this construct, the other thing that we provide is within the data center, and you'll see this term come up, there is a term called locally redundant. And so within a data center where most resources will get deployed, you are potentially subject to what happens if that data center fails. If this data center were to have an issue and you were to lose that data center that so happens to host your virtual machine, you could potentially run into an issue. We've got a construct that we'll be introducing in this module called availability zones and scale sets, where you can actually now deploy resources and it spreads it across multiple data centers within the region. So for example, I could have one VM deployed in this data center. I could have another VM deployed in this data center. And that way, if I were to lose a data center, my application would still run because I've got one version, or you can have up to 3 VMs in an availability zone. And if you have a scale sets, you can have thousands of virtual machines spread across multiple availability zones within that region you're dealing with. So great flexibility to take a look at some of the concepts that I'm going to introduce in this lesson, as opposed to just standalone virtual machines. So let's go back to the content. When you want to build a virtual machine, there's a number of choices that you have. You can read the list down the left-hand side. Naming conventions, you want to have a strict naming convention that you're following. You want to take a look at the resources that the VMs are going to need. We're not going to get into all of those right now. The types of storage, networking that goes along with this, as well as a monitoring solution to make sure that the VM is performing as expected. So we have these choices that you go through to build the resources themselves. While I was not going to get into the individual resources, know that not all resources are available in all regions. I just showed you a picture of US East. It gets everything first. Whether you need VMs with GPUs, whether you've got general purpose, we've got high compute and high memory virtual machines that are optimized for those types of workloads. So when I do the demonstration at the end of this lesson, you'll see that I will go through and there's a category in the graphical interface that groups a set of virtual machines, so you don't have to go searching through. In some cases, we have 700 plus SKUs or variations of VMs to be able to pick from. So really great variety depending on the kind of workload that you're going to be looking for. Here's one of those constructs that I was talking about. Standalone virtual machines we've covered so far, and hopefully it's fairly easy to work with. There's a version called an availability set, which is a grouping of virtual machines, one or more, that are similar. So you still build them. You can have 2 VMs and maybe they are slightly different. They have different names and you can put them into the same availability set. And what Azure does is consider them to be one and the same, and it will balance the load across those availability sets and the servers that are in there. It manages them from a perspective from updates and what are called update domains and fault domains. And it allows us at an infrastructure level to manage those group of servers equally. You would put a load balancer in front of them so that you now have multiple machines that are being able to manage that environment. Probably something very similar to what you're doing right now. Scale sets, though, are a new construct for most of you probably. Scale sets are a way to dynamically expand and contract resource allocations based around day of the week, day of the year, or based on some metric or CPU utilization. So you can have as little as 1 virtual machine, and depending on the CPU utilization, it can expand out dynamically up to 1,000 virtual machines in a scale set within a single region. We also have the ability to deploy virtual machines across multiple regions to provide regional redundancy you're working with. And we'll cover this through a wide variety of other deliveries throughout this series. Today, we're focusing in on Azure architecture and specifically the Azure Batch solution and where it fits into an architecture. Let's get into it. When you take a look at the variety of compute options, most people will be pretty familiar with the IaaS offerings of virtual machines. Hopefully, some of the other offerings like app service plans and Kubernetes and containers might be familiar with you. But the Azure Batch service, depending on who you are, may be foreign to you. And it's not used by everybody, but it's one that is very powerful for you to be able to then use if it fits a specific need. It provides large-scale parallel computing, also referred to as HPC or batch jobs. It's used extensively in the movie industry to be able to take digital recording mix it together with digital CGI images, and be able to put that together, not only for the final movie, but if you think about a thing called a daily, a number of our customers, our movie studios, they on a daily basis have to be able to do reviews, and they have to be able to merge all this stuff together. And so having this magical armor on top of a magical character, with, real live characters, just think about the amount of compute power that needs to be able to take all that digital data and merge it together. So Azure Batch is a great way to be able to perform this. When you take a look at how it fits together, it's actually fairly simple. It's amount of resources, and it's basically unlimited. And you'll see an example here in just a minute that I show you that says, take this data, in my case of my example of my movie, take this CGI of the eyes of this character, take the CGI of the fur of this character, take the CGI of the armor for this real character, and overlay that on the CGI, or on the actual character's digital video that we've shot. And we've got to merge all that data together. So there's my data store. So you see that at the top, an Azure storage account that you load your asset files into. I then have to be able to allocate a pool of resources. And I've got what are called the actual compute nodes and job nodes. And then I take the software and say, take this software, go get this data, and then stitch all this stuff together across all these all these machines that we're going to allocate to it. And depending on the job, you can allocate more or fewer resources to it. The fewer resources, more data, could take longer. You could shorten that period by adding more resources to it. So it's this very flexible way to be able to apply a large amount of compute resources for a short period of time to get a job done very quickly. But it's very, limited, I'll say, in the business application of it. It's used in test environments. It's used for machine learning. So there's some very big workloads that organizations may be running, depending on your organization, that this is highly suited for. Now, the example I was using for you earlier, we're quite proud of at Microsoft, and I'll put a link into an AKA short link if you want to see this story. But during COVID, there was a tragedy that some of you may remember that people needed ventilators. And these are highly specialized medical devices. And the redundancy that's built into them is amazing to be able to get that medical criteria or status. Now, the capability of it is quite large, but typically one ventilator, one person. And with so few ventilators, but so many people needing them, there was the unfortunate tragedy that some people had the choice of, who gets them and who doesn't. I just couldn't imagine having to make that choice. Microsoft, in conjunction with Duke University, we contributed over 800,000 hours of compute time over a 3-day period. Imagine the compute power to go by that. Take 800,000, divide it by 3, divide it by 24. You could figure out how many compute nodes had to be allocated to this. And what they were able to do, and the video shows, they were able to hypothesize the ability to, with a very simple plastic tube, go through all the simulations to be able to meet the medical requirements and certifications to be able to take a single ventilator and double its capacity. 800,000 compute hours over a 3-day period using something like Azure Batch. A compelling reason to take a look at what the service can do for you and why it might be powerful for you to use in your business solution. Today, we're going to be focusing in on Azure architecture and focusing in on the app services and how it fits into your solution. Let's get into it. When you take a look at traditional environments, I'm going to go off to a whiteboard session in just a second. You've probably built some level of infrastructure to deploy an app that is an HTTP-based app. So let's just get in here for a second on a whiteboard. I'll zoom in just a second, but what you're seeing is this could be a virtual machine, and you see 3 of them across the top, whether they be Windows or Linux, it doesn't matter. They run on top of maybe your infrastructure or even an IaaS world inside of Azure. So you've got a virtual machine running on top of Azure, the ARM layer you're seeing there. I've masked off some of the infrastructure pieces. We use this in other classes. That is eventually running on some Microsoft hardware in a data center down here at the bottom. So let's zoom in for a second and just take a look at what I'm talking about. In this traditional environment, on your virtual machine, you might have an app. So you've got app 1 here. running on a Linux box on a virtual machine in your IaaS or your on-premises world. On this box, you might have a Windows server and you might have app2 running on this one. It's up to you to build the application and host and maintain the environment below it. Wouldn't it be nice if I didn't have to deal with any of that? So let's take a look at what the app services will do for you. And I'm going to zoom back out just for a second. You're running a virtual machine on top of Azure. What app services provide for you is a platform as a service environment that takes those very similar virtual machines that we just were using, and instead of you managing and maintaining them, we move them down to the infrastructure of Azure. We have hardware and we build a virtual machine, whether it be a Windows or Linux machine. And I'll show all this to you in a demonstration at the end of this lecture. You get to pick. I want my application. So in here, your app2 that was running on a Windows box, you would then put it into this thing called an app service plan. Just zoom out of here for a sec. You create an app service plan. You put your app in it, and that plan gets executed against that resource. I would do the same thing. I would have an app service plan. And I would take my green app number 1, and deploy it just as I did before. Now, there are some limitations. We're not going to get into them now, but you'll also see in a migration app module that we cover later, you can actually rehost or refactor your application. Why do I need the infrastructure? If it suits the environment, I might be able to just take my application, abandon the on-premises IaaS workloads, and be able to deploy the exact same application. I had a customer that we did 6,000 applications. We evaluated them, 4,000 of those applications across roughly 18,000 servers for them globally. We were able to abandon those 18,000 servers and deploy those applications using the platform as a service. Now, yes, there's some initial costs that they're going to save. There's no longer 18,000 VMs that they have to pay for. There's no longer 18,000 VMware licenses they have to pay for. But the big savings for them, there was no longer 18,000 VMs that on a monthly basis needed to be patched. So taking a look at the app service plan and why you might want to consider it in your architecture is a potential huge savings for organizations. And you might hear the term either in your organization or somewhere else where they say, we're going to move to a cloud-first, cloud-native deployment. And that means we're going to abandon some of those thoughts that we've had about we have to own the infrastructure. Now, if you're worried about jobs, it doesn't really get rid of a whole bunch of jobs. It just makes the jobs and the time that you have to do them more impactful for the organization. So moving to an app service plan provides these traditional web app environments to deploy applications. They have automatic scaling capabilities. You'll see that in some of the bullet points. It supports a wide variety of languages that you'd be able to work with. The catch is they must be current versions of them, PHP, Java, .NET, and ASP.NET that you're working with. So we'll do that in the demonstration and show that to you. So as I said, a number of the considerations you want to take a look at, a lot of these web-based applications for mobile applications, your app services have things called deployment slots that provide for a CI/CD or continual integration, continual delivery, a modern way of building and maintaining your applications. They're built on top of a REST API that you're working with. It uses web jobs to run the programs and scripting. So as I said, it might take a little bit of work to understand the new model to manage and work with them. But in many, many cases, traditional applications, as long as they're relatively well maintained, can fit into an app service plan as part of the migration process. Today, we're going to be focusing in on Azure architecture and different compute solutions. And in this module specifically, we're going to be taking a look at Azure Container Instances as one of the options available to you. So let's get into it. As we take a look at application deployments, more and more organizations are looking at some type of either Docker or a container to deploy their application in a modern format. Containers are becoming more and more popular, but you have to make sure that you understand there's a distinction between the container to run the application and the orchestration or the management of the container. They're two different features. A container runs the application or the code. And there's a wide variety of container products that are out there. Probably the most popular one that you're familiar with is Docker. But there's other ones that are out there that run containered applications. And one of the benefits of a container is your code is transportable across the container environments. And whether that container exists on a Windows box or a Linux box or a Mac or an iOS, it doesn't matter. A container is a container that as long as you can host that container environment, you'll be able to run the application. So a very popular way for people to build modern applications. Well, that's great. Well, that's one container. But what happens if I need multiple containers because I've got a microserviced application and I need to have multiple containers talk to each other? What happens if I want them to scale, as we've talked about in other components like VM scale sets or in the app service plans, being able to dynamically scale out and scale in to meet your demand? How do I do that? Containers by themselves don't. That is done through a component called orchestration. And there's a wide variety of products that provide that orchestration. Kubernetes is probably the dominant one that you've heard about. So Kubernetes are the orchestrated environment of a container. We're going to show you in a later module a thing called AKS, or our container orchestrated environment, much like this one in this series. Microsoft has a standalone container environment. And for me, I think this is kind of neat from an architect's perspective, because maybe you have been building your applications in a traditional manner. You're used to maybe more of a web deployment of your application. And we covered this in the app service plan. And you're going, well, that's great, but I don't want to have to continue to build my applications that way. I want to get in with this modern application, but I don't want to have to learn all about Kubernetes and all the orchestration that have to go along with it. So what you're going to be able to do potentially is to say, hey, all new applications, wouldn't it be nice if I could put them in containers and not have to be strapped to this old method? I can still have them work with my current applications that might be running in web applications in an app service plan. But I can now add these containers as I bring on new microservices without having to go all the way to a Kubernetes environment. And as you start to develop that skill, maybe eventually, maybe you're at a 90-10 between traditional deployments versus a container environment. And over a period of time, maybe you're going to slip down to 60-40. But at a period of time, wouldn't it be nice if you become predominantly in the container environment? You could at some point in time now say, listen, I've got so much in my application container. Now I'm ready to be able to move over and take on a full orchestrated container environment and get the benefits of that full orchestration. Well, your application's all ready to go. You don't have to refactor the application at that decision point. You've already been building there. So container instances have a whole series of great features, but we're providing the capability for you to deploy a single container without all the orchestration. Microsoft also has a newer version that allows you to have somewhat of a light orchestration, and you can have multiple containers and some of the scalability that goes along with this. So I'll do a demonstration that's going to look very similar to what we did in the app services plan, because you'll see that come up here that you could potentially have the orchestration of a standalone container be orchestrated by the features of the app service plan itself. So a container instance could be a standalone container all by itself. It can exist as part of a container group that gets some light management that it's working with. It can be part of an app service plan that you're working with. So there's a whole bunch of ways to be able to take a look at the container instance itself. And so for those pros and cons I was just talking about, they're super fast and easy to deploy. It's that whole benefit of containers themselves. You can use them for these maybe non-production environments to get some skills and start working with them. I used a slightly different model of maybe you're going to just start to, even in production, but you're going to just take on new applications in that container. You can see that we use them for what's called AKS burst overflow, that we can now use that container instance to hit the high demand. So if you have an AKS solution you're working with and your scaling doesn't work at the rapid speed that you need it to, we can augment that with a container instance. And we talk more about that in the AKS course. It mentions that they don't scale, but that's by themselves as a standalone container, correct. But I can find a way, and I'll show this to you in the demonstration, how you could potentially, using app service plans, be able to get your containers to scale. Here's a set of lists of containers versus virtual machines. I love these diagrams that talk about the pro of why you use this one versus this one. It's a fairly simple list. I think I've detailed most of this for you of, your applications. Is it compatible with the container environment? Do you need some underlying operating system features? Because you're not going to have access to that in the container environment. You might need access to the host OS that you need to connect to or load some software on that you need the container to be able to work with. So a series of features. But today we're focusing in on Azure architecture and some of the design decisions around some of the features you may want to add to your architectures. Specifically in this module, we're going to take a look at designing for Azure Kubernetes Services, or AKS. So let's get into it. I'm not sure if you're familiar with a full Kubernetes environment, but I just want to cover some components that hopefully brings you up to speed so you can understand what the benefit of this is. If I take a look at what is a container versus orchestration, they are two different things. A container is the environment in which you run your code. There is a whole series of products, one being Docker, that does this. And so what it provides for you is a container that you can put in code to run. That's all it does. But if I need to scale these applications out, I need to manage them, I need them to talk to each other. This is where the orchestration comes in. And there's a series of products that provide orchestration, of which one is Kubernetes. Docker even has their own product called Swarm that they try to get people to use. But people have gone to this open source, of which Microsoft is one company, that is contributing to the orchestration of your containers. Now, what Kubernetes provides for you is very similar to a Docker container. You get a container that exists in a thing called a pod. That pod runs on a thing called a node. And that node, for all intents and purposes, is a virtual machine. So you might have a virtual machine with 24 cores. It's got 120 gigs of RAM. You can deploy multiple pods with multiple containers on that node. Well, I might want to have scale, so I might want to have multiple nodes in a thing called a pool. That's some of the orchestration that comes along with Kubernetes. So as you deploy more and more pods, how those pods talk to each other, how they exist on nodes, how much resources are allocated to them, and how we dynamically scale out the number of nodes in a pool is all done through the Kubernetes services. And that's what you're going to get in an AKS solution. You're going to get a well-deployed container environment along with Kubernetes and the node, your ability to build nodes, and we'll do this in the demonstration. You can build nodes, and you see the word nodes and pods scaling in there, is all going to be managed for you. But the infrastructure, the updating of Kubernetes and Docker, all of that stuff is going to be managed as a service, as a PaaS offering inside of Azure. So if you're managing a Docker container with Kubernetes right now, manage all that work that you do just to manage the environment is basically taken over for you. You still get to control it, but it's going to give you a fully managed Kubernetes environment with containers that you don't have to build the networking infrastructure. You don't have to build the container environments. You don't have to build the physical infrastructure. All of that goes away, but you still get the benefits of a fully orchestrated Kubernetes environment. Today, we're going to be focusing in on Azure architecture, and we're looking at different compute options, and then we're going to now look at designing for Azure functions. So let's get into it. Before I jump into the course material, I want to set the groundwork of where a function will go. People use the term applications, and applications are usually many lines of code that do very complex if-then-else kind of statements. Azure Functions perform a very specific capability for us in modern app development. What I'm showing to you is kind of a microservice version of an application across 3 multiple tiers. And while I may have an application that does this complex business process that I'm working with, I might be able to offload some of that business process to things like Azure Functions. They are highly tuned to perform unique tasks that need to be run periodically or in very fast succession. They scale quickly and they perform from a resource perspective very cost effectively. So I'm just going to give you a scenario of where an Azure function might come into play. What people are going to do is log into a web page. They're going to go into their account and they're going to upload images that they've taken. They're going to go into a storage account. And every time a new image appears in the storage account, I need to be able to have some stuff done to that storage account. I need the image to be sent off to a thing called image recognition. So it's going to go off to a thing called cognitive services. You might hear it referred to as artificial intelligence, but cognitive services is going to do an image recognition. I don't send the picture there, but I have to send a notification that, hey, there's a new picture. Here's where it is. Do some image recognition against that and categorize it. Is it a color picture? Is it outdoors? Does it have pictures of dogs in it? So do all that kind of stuff. That's a task. The next thing is, I also need a thumbnail because maybe you've taken your picture with a very nice, high professional camera, many megapixels, but I need a standard thumbnail that I could put that out onto a web page to make it available for people to pick from. So I need a thumbnail created. So I need a different image in a standard size and put it into a different storage account. I maybe need to write that information that came from the image recognition into the database. So now it has a record of that image with that categorization that people could send and search for. So instead of having to write an app that did all of that, it took it and sent it off to image recognition. It went it off into, it took a thumbnail and it then wrote to the database. I could break that up into 3 distinct capabilities. And why I might want to do that is, for example, maybe I bring on another part of my application that needs to send something off to image recognition. I don't need to have to call the application, then write statements to excuse or exclude the other parts. You can call an Azure function that based around a trigger. That word is going to come in very importantly in a minute. Based on some triggering activity, I want you to do this one thing. Another reason why I might want to do it, for example, credit cards. I can actually check a credit card number before it gets sent off to the credit card processing company and tell you if it's not your number. I can tell you if it's at least a valid number. And if you've transposed 2 figures, I'd be able to tell that at the time of input. So I could then write as part of my billing construct. I don't have to write that code into my purchasing part of my application. I could call an Azure function if and only when a credit card is put in, does it call the function. So I don't have to have it in my lines of code and have if then else statements that exclude it if it's not there. It says if a credit card is put in, call an Azure function, give it the credit card number and tell me if it's valid. So there's an example of why you might want to have something like a function added to your application development, because they become these very small, like race car types of code that do these very unique features and capabilities. They run very quickly. You only run them when you need them, and they can scale very quickly because they're just small lines of code. And you'll see a lot of these terms that are listed on here. And it fits within the range of applications that we've talked about. You're going to run your application maybe as a web app. You're going to run your application as maybe on an IaaS workload. You're maybe going to put it in a container, but that's for your applications. Azure functions meet this very specific need. You'll see that they scale easily because, again, they're very small lines of code. And if all of a sudden Monday morning, hundreds of customers come to the website and upload their pictures that they've taken over the weekend, I want it to scale out dynamically very quickly and do all this as opposed to only having one that's going to take potentially hours to do that level of work. It says that they're event-driven. They don't have to be. It's based on a thing called a trigger. And while there is one and only one trigger that a function can have, that can have a variety of triggers. There can be an HTTP or an HTTPS trigger. There could be an event trigger that says, in my example, when an image gets created, then kick off this activity. You could base it on a timed trigger. So once a day, once an hour, once every. So there's a variety of ways to create these triggers, but a function can have one and only one trigger. Again, why we try and make it very uniquely focused to do one and only one thing because of that triggering capacity that it's dealing with. It goes to something I was said, but maybe not really obvious, that promotes code reuse. Going back to my credit card processing application, it's called the LUN algorithm. The gentleman in the 60s at IBM came up with this process to validate numbers. Now, so it can check to make sure that the credit card number is correct, but it can also do national identities. It doesn't work for the United States social security number, but for example, in Canada, the social insurance number, very similar, the national identity that the federal government gives you, you can use it to check for a social insurance number being inputted. So if I was a Canadian company and I had credit cards and I needed SINs that are checked, I could use this code for both of those because it does one thing. It just checks this input value and tells you if it's valid or not. So there's some of the examples of where it can be done. There's a lot of varieties because by default, functions do something and then they go away and they do one thing. And so ways that you can actually make functions more powerful is creating a thing called a durable function. It's not really talked a lot about, but you can say if I needed to do 2 or 3 things and maintain state across a variety of operations, I could create a thing called a durable function. You'll see that as the second item on that bullet list. That says, I'm going to go back to my Canadian social insurance number. I can take that number, so I get an input number. It validates as, yes, it's a valid number, but the cool thing about the social insurance number, as well as the credit card number, not only could I tell you, is it a valid number, I can tell you where it came from. So for a Canadian social insurance number, it can tell you that, depending on the number that it calculated, I can tell you which province issued that. If it's a credit card, I can tell you if it was a Chase Manhattan or a Chase Visa. I can tell you if it was a Bank of America MasterCard. So I can tell you the vendor and I can tell you the type of card it is. So it's kind of a cool feature. And I might do that in a durable function, say, take this input value, tell me if it's valid, and based around this calculation, send it off to another function to tell me where it came from. So very unique capability in this microservice world to take a look at Azure Functions and how they can really benefit you in the architecture of your modern application. Today, we're focusing in on Azure architecture, and we're looking at different compute options, specifically how logic apps are a possible solution in the mix of the ways that you can deploy an application. Let's get in and take a look at this. In a previous lesson that you might have watched, we talked about applications, this complex set of code that some developer might have written. We talked about a thing called an Azure function that has one and only one thing that it does. Logic apps are another way of building an application. You might hear them referred to as low code or no code. In the demonstration that I'm going to do later, I'm going to show you how a non-programmer can use a graphical tool to literally pull together dragging and dropping features in to be able to perform an activity. And this way, business users that might have a need, instead of having them write up a request and put that request into a development environment that has to sit on the workload and work its way through to be able to potentially have weeks, months, or even longer to be able to have that code written and brought into fruition. Theoretically, you could actually have a person that had the necessary permissions go through and write this code themselves by literally, as I said, dragging and dropping it. So here's an analogy of why you might want to use a logic app. I've got a product manager that has just released a product, and he wants to be able to get some feedback based around some social media activities going on. As opposed to having to put the request in to have the code written, they literally could go into a utility, and I'll show this in the demonstration, where they could pull icon graphics for all of this and build this application themselves in a low-code, no-code environment. So I'll bring in a connector for the social media site, and it'll ask me, hey, what's the username and password that I need? And so you just put in those fields. And instead of having to know what are the APIs to make that call, you just literally drag it in and you're going to make the connection to that social media site. The next thing you're going to say, well, I need to listen for, mentioning my product. So you just literally drag in a piece of code, and it's got an icon that represents it. query based on subject. And so what's the subject? And you type in your product name. And then you say, well, I need to find those products. And if they find one, I need to pull that message in and send it off to this thing called sentiment recognition, an Azure service that can actually determine if people are happy or sad about what it is that you've just published. And so it can grab those necessary fields. It can grab who sent the social media post, what was in the social media post. It can grab all that information. Again, you don't need to know any of those APIs, and it can forward it off to sentiment recognition. The next thing I want to do is, depending on the feedback from sentiment recognition, is if it was a happy post, I want to repost that. So again, I have to connect back to that social media site and publish it as a repost. Or if it's a negative post, what I want to be able to do is to send it off to the product manager, have them review the comment and potentially reply to that person and or post what the fix is. And so all of that could be done literally with no coding. And that's the example I'll be doing at the end of this presentation. The nice thing about logic apps versus function apps or full applications, low code, no code capabilities, the ability to have multiple connectors that you're working with that are published. And there's hundreds of them out there that I can pull from, connecting to SAP, connecting to Salesforce, all of these different cloud services, as well as the ability to have that low code, no code requirement to build, as well as I can now have up to 10 triggering activities that kicks off the logic app itself. So a great tool for us to be able to work with. And so they're seeing some of those differences right now between the logic apps and even durable functions, because while a function by itself would never come close to what a logic app can do because there's only one trigger, but in a durable function, I could perform multiple activities, absolutely, but then it's still up to you to code those. And so you're going to see some of those features, where you see designer first versus coding first. Some of the difference between logic apps and durable functions and even functions. They all fit into the mix, but they're all very specific tools to be used on your tool belt. So now that we've taken a look at the various PaaS offerings that are available for us from a compute perspective, let's go in and do a demonstration of a number of them. And it's just a high level to show you how easy it is to deploy some of these and giving you an idea of what they are. To get into all of them would take quite a while, but we'll cover most of these. So let's get into that demo. The first of the demos I want to show you is the creation of the virtual machine and the various types of standalone virtual machines, availability sets, availability zones, as well as scale sets. As with all resources, they have to have a subscription that they're billed to. I'm going to assign this to an existing resource group. Now, the virtual machine names, you can make up whatever you want, but I strongly recommend that you follow the Microsoft naming convention. You'll see the link here to the defined naming convention, and it's a sample of what many of your organizations might have picked up some version of. So find out what your organization uses. The next thing you've got to pick is which region do you want this deployed in? And I'm going to switch between East US. Remember, I said this is our favorite region, gets everything first, just to show you some of the differences between US East and some of the other regions. So US East has all of the availability types of no infrastructure or just a standalone virtual machine, availability zones, availability sets, and virtual machine scale sets. The other thing that we have available to us is a wide variety of SKUs. These are the different sizes of virtual machines that we have available. I'm going to come back to this in a minute, but you'll see that we have roughly 785 different SKUs to select from in US East. I'm going to switch to Canada East just to show you some of the differences between regions that may not have all of the resources. So let's switch to Canada East. Now that I'm in Canada East, you'll see that the availability options that I have are no infrastructure or standalone virtual machines. So you see that I have no infrastructure or standalone virtual machines. You'll see that availability zones are not currently available in Canada East. And I do have virtual machine scale sets and availability sets. Let's go take a look at the number of SKUs that we have from a hardware perspective. And you'll notice that I only have 558 versions. So remember that not all resources are available in all regions. Let's continue the demonstration. So I'm back at East US, and remember the different types of availability. We can have standalone virtual machines. Now remember that virtual machines cannot be added to availability sets, availability zones, or scale sets after they've been created. It must happen at the time that they're created. I'm going to switch over to availability sets, and you'll see that it comes up with some options down the left-hand side to create what is an availability set. I don't have one currently, so I'm going to create one. And so some of the options that we get to configure is what is the name name of the availability set, and this can follow whatever naming standard you want. And this is where we can create the number of fault domains that I want to have in this availability set. And here you can have that maximum of 3. The other option that we have is the thing called the update domains, and you can see I have up to 20 update domains. Remember, these are updates that Microsoft is doing to the infrastructure servers that these virtual machines are going to be deployed to. This is not your updates. Taking a look at the availability zones, this is now going to spread them across multiple data centers within the same region. So in this case, US East, and I can pick which zone I want it to go to, zone 1, zone 2, or zone 3. So as I add new virtual machines to here, I should be careful to make sure that I'm not overloading a zone. Make sure that if your first one goes to zone 1, your second go to zone 2, the third could go to zone 3, the fourth would go to zone 1 in somewhat of a round robin fashion. The last of the options are scale sets. And in here, I can create a scale set if I haven't already got one built. Here, I'm going to have to create the scaling rules. Do I want this to be a manual scale or automatic scaling or no scaling profiles? I'm going to go to automatic. And this is where I can create a set of rules that will determine when and how this will scale out. I can add a scaling condition, and you can have multiple conditions in your scaling rule. I can have my first condition name, and I can base this around maybe day of the week, day of the year, or some kind of metric. When we get into the portal, I'll show you that you can actually adjust this and add more scaling conditions. So I'm just going to abandon this now, and I'll actually take this up after I've deployed a virtual machine. The other attributes that we can configure during the deployment of the virtual machine are which image do I want to build. Now, I've referred to this thing called the marketplace, and we have all of the currently supported versions of operating systems and flavors thereof. So all the current supported versions of Windows, you can see I've got Server 2022. Should have down here at the bottom, Server 2019, Server 2016. You can see I've got versions of the desktop operating systems with Windows 10 and 11. Now, if you need a version of Windows that is not currently supported, things like Windows Server 2012 and 2012 R2, 2008, you can build your own images if you want and use them to deploy as opposed to a marketplace image. You'll notice that I've also got a wide variety of Linux operating systems. I then pick which SKU I want. I'm going to go back in and show you some more of these SKUs, and you'll see that these are our most commonly used. We showed you that there are categories based around the type of virtual machines, whether it's a high compute requirement that range from as little as 1 core with 1 gig of memory all the way up to over 700 cores and over 24 terabytes of RAM. Other things you want to take into consideration is the number of data disks. We talked about the IOPS, and we'll talk more about this when we get into disks, but this one can support a maximum of 3,200 IOPS. There's other attributes not listed in this chart for things like what are the maximum number of network cards that it could have. Now, looking at some of the other options that we have, we can configure the operating system disk. And this is where you can pick the type of hard drives that the OS or your C drive is going to be deployed to. We have standard HDDs, standard SSDs, and premium SSDs. Now, these are going to range in price slightly, but also range from something as low as 800 IOPS all the way up over 50,000 IOPS that you're working with. I can attach additional disks for data drives if I wanted. So I could either create them or attach existing disks. Here's that monitoring tab that says, do I want to omit some of these features like diagnostic information, boot diagnostic, enable OS guest diagnostics? They can now be submitted to Azure Monitor. And then I get into the advanced feature where I can now work with extensions. And in here, I can provide 2 specific ones that I want to take a look at for automation for the post-deployment configuration of this virtual machine. So there are 2 that I want to point out. The custom script extensions is a script that you can write that would map network drives and provide a wide variety of configuration capabilities. If you can script it, you can have it be done in a post-OOBE or out-of-box experience deployment of a fresh operating system. And then there's desired state configuration, or DSC. This can actually contact a configuration server and bring this device into compliance with that desired state configuration, or report on its compliance as being not compliant. And then you can come in post-deployment and make those modifications. Final step would then to be review and create. I'm going to go actually into a scale set and show you some of the characteristics for scaling. When configuring a scale set, you can have manual scaling or custom scaling, where you can identify anywhere from 1 to 1,000 virtual machines using a marketplace image, or up to 600 if you're using a custom image, or we can create custom scaling rules. If you're building with custom scaling rules, there's a feature for predictive auto scaling that currently is disabled. You can have forecast only or enable this. When building your custom scaling condition, you can see that I've got a current condition that is based on a metric, and Microsoft recommends you have at least one one scale out rule and at least one corresponding scale in rule. You have minimum, maximum, and default values per scaling condition. You can add multiple scaling conditions. So in addition to my one for metric, I can scale to specific instant counts based around some rule. And we recommend once again that you have a scale out and a scale in rule with our minimums, maximums, and default values for this scaling condition. And then we can have a day of the week or a day of the year scaling. I now want to do a demonstration of how we determine the number of units when you have multiple rules across multiple conditions. What you're seeing is an image of a scaling condition for a metric. You'll notice that I have two different scale out rules. And once you do that, the statements become an OR. And so I've got one that's based on a count, and I've got one that's going to be based on a percentage. And I have a single scaling in rule. Now let's take a look at what happens when you have multiple conditions with potentially multiple rules. Here I've got three different scaling rules. I've got one for metric, I've got one for a day of the week, and I've got one for a day of the year. Within each of these scaling conditions, I have a scale out rule that has two scale conditions that are ORed. And I've got a scale in rule that is going to remove a unit. And I've repeated that across all three. So the rule is Microsoft will never under provision. So when you have two different scaling rules to scale out, whichever is going to yield the most, adding 1 or 10%. So if I've got 20 units, adding 10% would give me 2 in this case. So that one would win. If I then have my rule against the day of the week, I have multiple conditions. And let's say that this one was going to yield 3 units for me. And then on the day of the year, I have an OR statement. And for this day, there was going to be 0 or very few. When I then have multiple conditions that I'm looking at, the one that has the most units is the one that will be determining the number of units that would be scaled at that moment in time. So remember, Microsoft will never under provision. We've just looked at the IaaS offerings, or the infrastructure as a service for deployment of virtual machines. Let's now switch to the platform as a service, or PaaS offerings, using an app service and app service plan. I'm going to go ahead and create a web app, which is the application space in which my code, my actual application, run. Applications run in app services. App services run within app service plans. I'm going to put my resources into a resource group. And when I name my resource, you want to follow a naming convention, and this name must be globally unique. I can run my app service as either code, a container, or a static web app. If I'm going to select code, we can run across a wide variety of currently supported runtime environment. You'll see I've got .NET, ASP.NET, Java, Node, PHP, and Python that are available to me. Now, while these are only currently supported versions, it may mean that your application may still run. It just depends on which APIs were deprecated and does your application use them. So we do strongly recommend that you try running your applications. Even if it uses an older version, it may very well run. You put your app service into a region, and then you either select an existing app service plan or you create one in that region. The app service plans vary based around the number of resources as well as features that are available through that app service plan. You'll see here that we have a variety of free, basic, standard, and premium plans that are available, as well as isolated, that each allocate a number of CPU and vCPU, memory, and capabilities to that app service plan. The number of features range from custom domains, auto-scaling features, whether it's manual or rule-based. And this is going to follow the same rule structures that I showed you in the IaaS virtual machine scaling capabilities. So the same sets of, you have multiple conditions, you can have multiple rules that you're working with, but exactly the same process is followed for that scaling if it's supported. Now, while they're referred to as staging slots on this diagram, you'll actually see them referred to as deployment slots throughout the documentation and other graphical interfaces. Let's return to the lesson. So welcome back from the demo. Hopefully that was giving you a flavor or a taste of some of the compute options that are available for you. Now, we did a lot of that in the graphical interface, and it would be our recommendation that as you move into production and at scale, the best way to do that would be done through templates, deployments, or some command line infrastructure that you've built. So what we covered was those PaaS or platform as a service offerings. And that would be our recommendation, that as you take that traditional on-premises environment for deploying your applications, if they typically deployed on a Windows or a Linux environment, they would very easily be suited for one of these PaaS offerings that you had. We saw that the app service plans was ideally suited for, a typical application, whether it be Java, PHP, .NET, or even ASP.NET. We had infrastructure of Windows and Linux to be able to provide that for you. And it really freed you up from the need to have to build and maintain and pay for all of those virtual machines that you've typically been running on premises. We then moved into some of the modern application design from that monolithic application, looking more at the microservices. And we saw that we had a series of containerized offerings available from us, from standalone containers to a container service that provides some light orchestration, all the way up to a fully orchestrated Kubernetes infrastructure running as a platform as a service, where Microsoft builds and maintains the infrastructure. You just consume and manage the Kubernetes environment for the deployment of your containers. We then took a look at various forms of being able to enable that modern application development in the microservice world. We looked at things like Azure Functions and the ability to extend application development out to that low-code, no-code environment using Logic Apps. So hopefully that gives you a great grounding of application deployment capabilities and design requirements that you might have in your architectural solution. I look forward to seeing you in our next lesson.